For 73 seconds, everything looked perfect. 7 astronauts were climbing into the Florida sky aboard one of the most advanced machines ever built. Families watched. Students watched. Teachers watched. America watched. Then, without warning, the shuttle vanished inside a cloud of smoke. There was no time to understand what had happened. In less than 2 minutes, a mission meant to inspire a generation became one of the darkest moments in NASA history. To understand how it happened, we have to go back to the morning of January 28, 1986, at Kennedy Space Center, the Space Shuttle. Challenger stood on the launch pad beneath an unusually cold Florida sky. Its mission was called STS-51L. On board were 7 crew members: Commander Francis Scobie, pilot Michael Smith, mission specialists Ellison Onizuka, Judith Resnick and Ronald McNair, payload specialist Gregory Jarvis, and a passenger unlike anyone NASA had ever sent into space before, Christa McAuliffe. She was a high school social studies teacher from New Hampshire, chosen from thousands of applicants for NASA's Teacher in Space project. Her presence transformed the launch into a national event. Schools across the United States prepared to watch one of their own go to space. McAuliffe planned to teach lessons from orbit. For millions of children, this was not just another shuttle mission. It was proof that space could belong to ordinary people too. But behind the excitement, engineers were worried. The night before launch, temperatures at Kennedy Space Center had fallen far below normal. Ice formed around parts of the launch structure. Some engineers from Morton Thiokol, the contractor responsible for the shuttle's solid rocket boosters, were concerned about rubber seals called O-rings. These seals helped prevent hot gases from escaping the boosters. Cold temperatures could make the rubber less flexible. And if an O-ring failed at the wrong moment, the consequences could be catastrophic. During discussions before launch, engineers raised concerns about the unusually low temperature. The decision was debated. Eventually, the launch was approved. By morning, the crew was strapped inside Challenger. The countdown continued. The sky was clear. The cameras were ready. Families smiled from the viewing area. Across America, classrooms waited. At 11:38 a.m., the engines ignited. Challenger rose from the launch pad. For the first minute, everything appeared normal. Mission Control tracked the shuttle as it accelerated higher into the atmosphere. Then the crew received permission to increase power. Seconds later, cameras captured something no one understood yet. A small plume appeared near the right solid rocket booster. The astronauts continued climbing, and America continued watching. No one knew that the final seconds had already begun. At 11:38 a.m., Challenger left the launch pad. For the first few seconds, the flight looked exactly as millions hoped it would. The shuttle climbed above Kennedy Space Center on a column of brilliant white exhaust. Families cheered from the viewing area. Teachers and students across America saw Christa McAuliffe begin the journey she had spent months preparing for. Inside the cockpit, the crew followed the familiar rhythm of launch. Calls came from Mission Control. Instruments were monitored. Challenger accelerated toward the edge of space. But cameras on the ground had already recorded the first warning. Less than 1 second after liftoff, gray smoke appeared near a joint in the right solid rocket booster. Inside that joint were the O-rings engineers had worried about before launch. The unusually cold temperature had reduced their ability to seal quickly. For a time, combustion residue blocked the opening. Challenger kept climbing. To everyone watching, nothing seemed wrong. About 37 seconds into flight, the shuttle entered strong high-altitude winds. Its guidance system automatically corrected its path as the vehicle passed through turbulent air. Then, less than a minute after liftoff, cameras detected something far more dangerous. A flame appeared from the right booster. It grew. The escaping hot gases began striking the enormous external fuel tank beside it. Mission Control still had no clear indication that the vehicle was approaching catastrophe. Near 70 seconds, Commander Francis Scobie acknowledged the familiar call. "Roger, go at throttle up." Those were the last clearly recorded words transmitted from Challenger. Seconds later, the failure accelerated. A structural attachment between the right booster and the external tank gave way. The tank began to fail. At 73 seconds after liftoff, Challenger was engulfed in a massive cloud. as the vehicle broke apart under extreme aerodynamic forces. Mission Control lost telemetry for several moments. The communication loops reflected confusion rather than comprehension. Controllers searched their screens. The flight director asked for information. There was none. Then came the terrible realization. Challenger was gone. Across the United States, classrooms gathered to celebrate a teacher traveling to space suddenly fell silent. Parents, students, NASA employees, and millions of television viewers had witnessed the disaster almost in real time. The mission that was supposed to make space feel closer to ordinary. Americans had instead become a national tragedy. 7 people had boarded Challenger that morning. None would return. And almost immediately, one question began to overshadow every other. How could this have been allowed to happen? In the days after Challenger, grief turned into questions. How could a spacecraft carrying 7 people be lost only 73? Seconds after launch, President Ronald Reagan created a special commission to investigate the disaster. Its task was not simply to identify what failed. Investigators examined launch footage frame by frame. They studied engineering records and interviewed NASA officials, contractors and engineers who had raised concerns before liftoff. Eventually, the answer became clear. The immediate technical cause was the failure of the O-ring, seals in a joint of the right solid rocket booster. The unusually cold temperature that morning had reduced the rubber's ability to seal properly. Hot gases escaped through the joint. The leak grew until it damaged nearby structures and helped trigger the breakup of the vehicle. But the investigation uncovered something even more disturbing. The O-rings had shown problems before. Engineers knew cold weather could make them less reliable. On the night before launch, some Morton Theacle engineers argued that Challenger should not fly in such low temperatures. They recommended delaying the mission. During a tense conference, managers reconsidered the recommendation. The launch was eventually approved. Challenger had not been lost because of one defective piece of rubber alone. Technical concerns, schedule pressure, and communication failures had been allowed to collide. NASA suspended Space Shuttle flights. The booster joints were redesigned. Safety procedures changed. Management and communication practices came under intense scrutiny. For more than 2 years, no shuttle carried astronauts into space. Then, on September 29, 1988, Space Shuttle Discovery launched on mission STS-26. America's shuttle program had returned. But it returned different. The 7 members of Challenger were never treated simply as names in an accident report. Francis Scobie, Michael Smith, Ellison Onizuka, Judith Resnick, Ronald McNair, Gregory Jarvis, Christa McAuliffe. School scholarships, centers, and memorials would carry their names. McAuliffe's dream of teaching from space also survived. Decades later, astronauts carried out lessons connected to the mission she never had the chance to complete. Challenger changed NASA because it forced the agency to confront a painful truth. Advanced technology does not eliminate human judgment, and when people stop listening to warnings, even the most sophisticated systems can fail. The mission lasted 73 seconds. Its lesson has lasted for generations, and perhaps that is why Challenger is still remembered today. Not only for the moment, America watched a spacecraft disappear from the sky, but for the warning left behind when the silence began.